Hello, and welcome to the talk that I'm going to do today, which is entitled, Will Software Eat the World? So this is the question that we're going to be asking, and it is the question that we're hopefully going to be answering. And we'll be talking about the role that cloud native, the vital role that cloud native plays in making sure that software will not eat the world. And it's something that a lot of people don't understand. Cloud native plays an enormous role in this. So my name is Anne Currie, and I am the author or the co-author of two books that are very relevant to this topic, and they are the books that we're going to be talking about today. The most obvious one is the new O'Reilly book, Building Green Software, that came out last year, about the practices and the principles that are required to build software systems that are ready for the energy transition, that will create as little carbon, or emit as little carbon as a result of their operations as possible. But more subtly, and just as importantly, I'm also one of the co-authors of a book called Cloud Native Attitude that first came out 10 years ago. We just released the third edition of it, which is about the principles of cloud native and the principles of operating successfully in the cloud. Now, it might seem that those books are totally unrelated. How is cloud native and being green the same thing in any way? I'm going to make the argument today that they're incredibly related. They are incredibly aligned, and that in fact, cloud native is, unbeknownst to most folk, probably the most effective tool we have in our toolbox for building systems that are ready for the energy transition. So that's what I'm going to be talking about a little bit about today. And we're going to start by taking a little journey back in time to the foundations of the cloud. We're going to look at the definition of cloud native. We're only quickly going to go over this, but it's very relevant to the argument that I'm going to be making today. So I think most of you in this room will know that the original definition of cloud native was container packaged, dynamically managed, dynamically orchestrated, these days Kubernetes, systems that are microservice-like, which effectively just means not monolithic. But what you might not realize is why. Why was this definition of cloud native come up with? What was the purpose of it? Why was it invented in the first place? And you might think, it was invented by Docker about 10 years ago, and it was all about fast flow and getting products to market faster and all that kind of stuff. And it is certainly very useful for that. But that is not why it was invented. It was actually pioneered more like 20 years ago by Google. And the reason they pioneered it, the reason they came up with this way of architecting systems was to solve two very critical problems that they had that only appeared when they first started building hyperscale systems. The first was that systems at an incredibly hyperscale, if you ran them in the old way that we used to run and operate systems, they were just too expensive. They required huge amounts of hardware and electricity to run. It was just too expensive. But the other problem with hyperscale systems 20 years ago when they were first mooted by Google was they were too unreliable. That if you've got a system that is enormously huge and has millions of CPUs associated with it, has loads of machines, statistically, those machines fail a lot. They're constantly failing. So you have to architect a system that is resilient to failures in those systems. And that became really the two reasons for building cloud-native systems. One was to minimize the amount of hardware and electricity used by that system. And two was to make that system, to architect that system in a way that was resilient to failures or variations in the availability of the resources that underpinned your system. Which is interesting. In the last 10 years, I've been very much part of the green software movement. And I was involved in the early days of the Green Software Foundation, wrote the O'Reilly book. And if you were going to define green software, I think you'd really define it in terms of two things. One is that it is a system that minimizes resource usage. It minimizes the use of hardware, which contains a lot of embodied carbon or embedded carbon, and it minimizes the amount of electricity used by that system, because, again, that is often associated with carbon being released into the atmosphere. But also, the other slightly less well-known feature of a green system is that it has to be built so that in the future it can run on solar and wind generated electricity. And solar and wind generated electricity is not a like-for-like replacement for fossil fuel generated. It's much more variable. So you have to run a service that's extremely available on top of the variably available low carbon power from solar and wind. But that's quite interesting. Let's go back. So a cloud native system is about minimizing resource use, was originally about minimizing resource usage and providing a reliable service on top of something that was at hyperscale innately not reliable. And a green system is about minimizing resource usage and running on top of something which is not as reliable as the fossil fuel generated electricity we're used to today. Fundamentally, they're extraordinarily aligned in terms of what they're attempting to achieve. So let's park that for a moment. Let's hold that thought in our heads and move on and talk a little bit more about green software. So green software, in order to achieve those two goals of minimizing resource use and making your system more resilient, we tend to say there are three levers that you have and that you need to pull to achieve that. The first lever is operational efficiency. It's basically running your systems on less hardware, whilst still providing the same level of service. So that cuts your cost and it makes your systems greener because you're running on less hardware. The next lever that you have to pull is code efficiency. So code efficiency is about running your systems and providing the same functionality and the same levels of service on fewer CPU cycles. Because the amount of CPU calls that are made is very related to the amount of electricity it uses, and electricity at the moment is often not generated in a green way. And the final lever that you have to pull in building green software is the ability to time shift and location shift your workload. So identifying CPU intensive workloads that you have and trying to make them less time sensitive so that you can shift them to when the sun is shining or where the sun is shining or the wind is blowing. And here we hit another issue which is in some ways similar to the cloud native issue. I'm sure a lot of you are building cloud native systems, are used to cloud native systems, and what you will have learned is that there are lots of levers to pull and people get quite confused about which ones to pull when. Because all of these levers are easy and more effective for some companies to pull at some times than other companies at other times. And me and Sarah, my co-authors of Building Green Software, we went out and we talked about this a lot. And what we learned quite quickly was that people were trying to pull the levers in the wrong order, and it was getting them quite confused. And it was causing green projects to fail, because they were trying to do something that was very hard and didn't necessarily have the most impact for them, given who they were. So we thought, as part of writing the book, we thought we had to address this. We needed some way of getting people to pull the right levers in the right order. And we realized that there was a tool out there, a project management tool that existed for a long time that could help with this. And it was called a maturity matrix. Now, if you haven't come across the idea of, haven't heard of a maturity matrix before, it was invented at the Carnegie Mellon University of New York in the 80s to help deliver on difficult projects that people were struggling with a little bit. It is actually a matrix, and I don't expect you to look at all the details. So we put it in Building Green Software. We also donated it to the Green Software Foundation, so there are plenty of open source versions of this out for you to have a look at the detail of. But here, I don't necessarily want to be talking about those details. I think there are two quite subtle but killer concept about a maturity matrix that I think it is very important for us to take away if we want to be successful at building green software. The first thing the maturity matrix does is it defines what good looks like, which is very important when you're delivering a complex project. So in this case, what good looks like was defined again by Google some years ago, and it was something called 24/7 CFE, or 24/7 carbon-free electricity. And it's the idea that for a green system running in your data center, for every watt of power that system is drawing from the local grid in order to operate, a matching watt is going in from a low-carbon source at exactly that same time. So completely time-matched. And that's an incredibly interesting, that defines what we're ultimately going for. And Google defined that, but they didn't say they were going to achieve it immediately. What Google have said is that they intend to achieve that 24/7 CFE by 2030. That is quite some time off. Even though they are the world leaders in doing this stuff, they've still set their deadline for doing this. It's not tomorrow, it's quite some time off. And as I say, they're already massively ahead of everybody else. But right now, it is, I would say it's not, the knowing what good looks like, knowing what we're going for, it's useful, it's a useful element of a maturity matrix, but I don't think it is the most important element of a maturity matrix. The most important for where we are now is that a maturity matrix says, do not attempt to get to the top of that. Don't attempt to get to where you want to go in one go, because it's too hard. You're going to have to get there using gradual steps. And maturity matrix rather arbitrarily defines 5 steps to get there, and we're quite happy to stick with that 5 steps, with those 5 steps. And at each step, you should have a clear win, a clear milestone. Getting there should be good for your business in all kinds of ways, but you have to go through those steps to get to the end, and do not attempt to step over any of them. So what kind of steps are we talking about here in this green software maturity matrix? Level 1 is the desire to get to the end. It's the desire to build systems that are aligned and ready for the energy transition, that are aligned to run on solar and wind when the grid is primarily powered by that. So everybody in this room is at least at level 1 because you are here. If you're listening, you are showing interest, and don't underestimate that. 10 years ago, nobody cared about this stuff. It is incredibly important that we have reached level 1. Level 2 is something that I rather rudely refer to as basic operational competence. And again, don't underestimate the fact that don't overestimate the number of people who have reached basic operational competence. And this is really, in my mind, knowing what's going on in your data centers, knowing what's going on your VMs, knowing what's going on in your containers, making sure that you have control over that. And it's, in fact, I would argue, the most important step in the entire maturity matrix process. It's often associated with, it's manual. It's maybe manually every 6 months, every year, you go through your systems and you look at what's going on all your machines or your VMs or your containers, and you say, is that over-provisioned? Because almost everything is over-provisioned to start with, it gets over-provisioned over time. As long as you have to keep going back and right-sizing everything. Otherwise, your whole system will be over-provisioned. The other thing you might find during this manual process is you might find machines that really nobody's using anymore, systems that nobody is actually querying, nobody cares about, and turn those off. Because not only are they wasteful in terms of carbon and in terms of cost, you're paying for them, they are a security hole in your system. If you're not looking after them, you're not watching them, you're not keeping them patched, they are the way that hackers get into your system. And this level 2 of the maturity matrix is often associated with thriftathons, people going through and trying to cut their carbon bills. It's often associated with security reviews, security audits, going through and making sure you know what's going on in your data centers. And it usually does. We find that most people who do this, even this manual process, at least the first time, and often every time, you'll cut your hosting bill by 30 to 50%. Because everything is over-provisioned to start with. So that's level 2. Level 3 is what I would call absolutely excellent cloud native operations. It's taking everything you did at level 2 and automating it so that you don't have to do a manual process every 6 months, every year. You are running this. This is happening automatically. It's often associated with infrastructure as code, with CI/CD, with GitOps. It is really good operational competence, and you're no longer reliant on that manual 6-monthly or 12-monthly process. If you're in the cloud, there are lots of tools to help you do it, like multi-tenancy tools, spot instances, using the right instance types, burstable instances, serverless. So everybody in this room can benefit from that. But what about level 4? Well, level 4 is when actually you're looking at your systems and you're saying that system needs to be more efficient, needs to be code efficient, needs to be written in a language like Rust, it needs to be using things like eBPF to be more efficient. That's quite considerably more difficult. And then level 5, it's even more difficult, is you're just tuning that. You're getting that to the point, at level 4 and level 5, you're actually starting to automatically shift work to when the sun is shining or the wind's blowing. So it is a degree more difficult. And you might be looking at that and thinking about it and saying, well, this is all very well, but it's certainly to the advantage of every company to reach level 4, reach level 1 and 2 of the maturity matrix. It's just, as I said, basic operational competence. Level 3, it's hard enough as it is, but it is just good cloud-native operations that with all of the improvements in security, the improvements in resilience, the improvements in cost that come from being very good at operating your systems. But level 4, that's really hard. If most enterprises, if they tried to do it, they would actually go out of business. Writing your systems in Rust requires an incredible investment that is not the kind of investment that most enterprises should be making. At level 5, that's just going crazy. There's hardly any enterprises in the world that are even at level 2, never mind at level 4 or 5. At the moment, Google is only at level 4. Azure is only at level 4 in parts. AWS is only at level 4 in parts. So how can we expect everybody to get to level 5? And we need everybody to get to level 5. There is only one way. Me, Sarah, and the various other people that I talked to about this came to the conclusion there is only one way that it can be achieved, which is that we find green platforms that will do that rewriting in Rust for us, will do that aligning workloads with a green grid for us, and we move our systems. At level 3, we get our operations teams to identify those systems and help us to move to those systems. And then we keep putting pressure on those systems to take us up to level 5 under our feet, so that enterprises do not have to rewrite anything in Rust or C. And I used to be a C developer. I'm not dissing C, but don't do that. It's very expensive, and these systems end up being quite brittle. So what we are looking for is systems that will take us under our feet up to level 5, and that is the only way that we're going to get there in the long run. Cloud native is one of those systems. Cloud native used well, picking a platform that will do that for us. And if you want to help with picking a platform, if you're in the cloud, you can always go to one of the cloud's architectural sustainability pillars and have a look at see what platforms within the cloud they are pushing. So that might be the serverless platform, it might be spot instances. And you need to talk to your service provider and say, look, I really, really care about this. Is this going to take my system? If I invest in using this system well, will it carry me under my feet up to level 5 of the maturity matrix? And make sure you hold their feet to the flame to ensure that it does. Because particularly with the clouds, they're very responsive to customers asking for things. But if you don't ask, you won't get, because it's quite expensive and they'll just stop doing it. They'll just sneakily stop doing it for you. So doing cloud native well is astonishingly aligned with being green in the long run. So good luck. You all need to do it, and you need to do it well. So I'll be here for the rest of the day, and I'm very happy to answer questions now. We can ask, if you have any questions, I could talk about this for hours. Do ask questions now, but if you don't feel comfortable asking questions in front of everybody, I will be around for the rest of the day. Please come and ask me questions. And if any of you run a podcast, very happy to be a guest on your podcast, or you can ask me questions on LinkedIn. Now, I put this little bit up at the end about AI, because I think that many of you may have questions to ask about AI, and this will give you a little hint about what I think about it. But yes, any questions? Very happy to ask them. Thank you very much.
Round of applause. Are there any questions?
Hi, thank you for your talk. You mentioned that everyone needs to be at level 5 in the end. So I have workload, I don't run it because I have electricity, but I have users, and users are not active maybe when the sun shines or the wind blows. So how do you respond to such things like customers working at night or using the system at night? How would you manage that?
Well, so it's an excellent question, because there are multiple ways that you're going to have to pull those 3 levers that you've got, basically. The first thing, say, is operational efficiency, is that first of all, you just make your system so that it is unwasteful. And that usually will cut your carbon emissions in half. So the first thing you do is that. Then after that, you start to look at things like automating, auto-scaling, all that kind of stuff. So you're really trying to shrink as much as possible the amount of work that's going on at a time when there really isn't any sun shining or wind blowing. And it's amazing how much more efficient code is than non-code efficient code. I think people don't really realize how much more efficient it is. It's often 1,000 times more efficient, even 10,000, 100,000 times. I've seen people have told me about tweaks they've made to open source libraries, for example, that have increased its efficiency 1,000,000-fold. But you shouldn't be making those changes, but you should be demanding those changes of the platforms that you're using, so that the platforms become very, very efficient and don't use a great deal of power when the sun isn't shining and the wind isn't blowing. So you shouldn't be doing the work, but you should be reaching out to your platform providers and saying, what's your plan for getting this down to use a really tiny amount of electricity? Because it can be done, they just don't tend to do it because it's a lot of work. But you want to find a platform provider who will do that work for you. But as much as possible, you move it, if you can, make it time insensitive and move it to when the sun's shining or the wind's blowing. Did that answer your question?
Yeah, partly. Thank you.
Albert, no, no, we've got more questions. You can come back later.
Just a small question. As a cloud user, I don't see any clouds having electricity-based pricing. How do I detect that? How can I have long-running tasks. I don't have to run them every day at 2 o'clock in the morning, and I want to move them when electricity is available. Where can I do that?
Yes, so you're absolutely right. This comes up over and over again. In the long run, we absolutely need dynamic electricity pricing. Time of use tariffs, where we pay more for electricity that's dirty and less for electricity that's clean. We know that it's coming, but it is not at the moment available through the cloud providers. Now, I don't think that means the most effective thing you can do at the moment is move to somewhere else where you can do it. Ironic, the most effective thing you can do is, again, is the easiest thing, which is just to say to the cloud providers, I'm desperate for this. I really, really want it. When's it coming? When's it coming? Just demand from them. It's amazing how few customers actually ask for things like that from cloud providers. You don't need to ask very much. Only if everybody in this room asked that question, AWS, for example, would go, my goodness me, we really need to do something about this because we're getting asked an enormous amount about it. And it's almost no work for you to do that compared to actually acting on the data, which will be a lot of work for you to do when that data is available. But what you can do is line up your systems so that when the data is available, you can act on it. It sounds like you already have some ideas and you're already quite ready to use the data. So you can say to AWS, I'm ready to use this data, give it to me. But that's really, if you're in the cloud, your best option at the moment.
Thank
you. Thank you. Very inspiring talk. I was wondering, your new book, do you have it with you here? Like, is it available to get here?
Yes, both the books are available to buy on Amazon or all good bookshops. So yeah, you can just go onto Amazon and you'll Google my name and you'll see it come up.
Right.
Actually, Google's terrible at it if you put your name in. But if you Google the title of the book, it'll come up quite quickly.
All right.
There is a question up there.
I don't think I can throw
Try it with multiple steps.
It's like the maturity matrix. Don't attempt to do it in one go. You can only be successful by throwing it in stages.
So thank you very much for your inspiring talk. Sam Altman, the CEO of OpenAI, said like a month ago, it costs them multiple $1 million when you are polite using AI because it increases the number of tokens. So basically, the cost is also using power consumption for the GPUs. So do you think it's acceptable as a society starting to be unpolite and more direct to basically be greener and save power consumption?
I think the right way to handle this is very aligned with what we've just talked about. Is to put pressure on your provider, your platform provider, to do it. Because although you say thank you and it goes off and does a whole load of work, it doesn't need to. It could just cache that's you're very welcome, and give it back to you. It should not require, if things that require behavioral change from users are not scalable in the way that changes that are made by providers are scalable. So AI is a fantastic example of this. I don't know if people have had a look at. I think that DeepMind is a really, really good example of how much more efficient AI can be if people put some effort into making it more efficient. So DeepMind came on the scene at 10 times more efficient than OpenAI at doing similar stuff. And the reason they did that was they just applied stuff that we already knew would make AI workloads more efficient. So they put the effort in. They put the effort in because they had to, because their Biden government had reduced China's ability to access fancy NVIDIA chips that only had cheap chips. So they just changed what they did. So they did less whilst producing the same results that could be done on a smaller chip. Sometimes being forced to, well, actually not just sometimes, all the time. If you're forced to be a little bit more efficient, you can be. There's amazing amount of waste in all systems, particularly AI systems, because they're very new. They can be made considerably more efficient. And it's not about changing your behavior as a user. It's again about putting pressure on the AI creators, the AI makers, to deliver the service that you expect with fewer CPU cycles.
I think you mean DeepSeek.
Fewer GPU cycles.
One last question.
Hello. Still on the subject of AI, we are seeing massive data center coming online and projects that are creating that are really huge in terms of power consumption these days all over the world. We're talking about at least doubling in many places, but sometimes much more than that in terms of like energy consumption. And AI is going to be consuming, if it keeps on the track that it's going now, it's going to be consuming on the scale of like large cities very soon. Are you at all concerned about that? And do you feel that maybe anything that we can do to optimize our current workloads, is all those savings are going to be lost because just the scale at which we're starting to employ AI everywhere, both in our personal life and at work, is just going to eclipse any saving we make elsewhere? So
the question of, do I think, that the rate at which AI is consuming energy cannot go on at the rate that it is. But there's quite an interesting quote that I always like to use, which is, if something cannot go on, it won't. It'll stop. And AI, we're consuming, it's unbelievably inefficient at the moment because everybody's in a race. They're just going, oh, let's just type out this code. We won't make it in any way efficient. So the energy use is going up like crazy. But actually, I mean, as I said, DeepMind came along and with very, very small changes, cut their energy use by tenfold. And I think the next DeepMind model that comes out, it will blow you away in terms of how much efficiency it has introduced into AI, how much cheaper AI will be. And then the companies that haven't really spent any time and energy and effort putting into making their systems more inefficient will be left without the knowledge, with systems that are incredibly expensive. So fundamentally, we are going to see things go up, and then people like AI, DeepMind, are going to come along and say, "We're just, you're wasting money there. We're now running our systems on a tenth that price," and then everybody is going to start making their systems more efficient. Because do not underestimate how much efficiency saving there is to be made in AI. It is just code. It's not magic, and the same kind of tools that we've been talking about over-provisioning, about not having the right architectures, apply on steroids to AI. Everybody's just piled into it and are running a race, and they haven't done any efficiency changes. They'll be forced to. So I'm not as panicked about that as you might expect.
Thank you very much, Anne.
Well, thank you very
Round
much.
of applause.